So while Ricardo starts sharing, I want to just kind of preview briefly his paper. So this is one of my favorite papers in this space. And when I saw this pop up on, I think it was SSRN, I was super excited. Just from the abstract, you'll see the paper is enormously ambitious, just in the scale of what it is trying to achieve. You'll see why now you've seen some of my own work. Why I'm excited about it topic wise, and it fits sort of very closely what I want to do. But just the ambition of setting out and doing it this way, I thought was just really, really cool. So I'm very glad that Ricardo's agreed to also spend some time with us now and then again on the panel to discuss both sort of this specific work first, and then also just his thoughts on the field and where it should go. So Ricardo, the floor is yours. Look forward to seeing it.
Thank you so much for the invitation to speak, and also for the great introduction. The only bad thing is that you set the bar very high, so I can only disappoint the people watching right now. From now, let's go. I don't disappoint them too much. So this is joint work with Nicholas Botan from Cornell University, and the title of this paper is Betting on the House, Subjective Expectations and Market Choices. So I'm pretty sure that at this point in this course, you have heard a lot about subjective expectations. I will give you one way of summarizing the literature of the last 20 years, very briefly. It's very unfair. It's just one way of summarizing it, which is the following. We start with the benchmark of rational expectations. At some point, economists start using surveys in order to measure the actual expectations of the people, what they say about the future inflation rates or the future home prices. And one thing that we find is that, hey, sometimes on average, people get it right. They seem to report expectations that are in line with what the professional forecasters are saying, let's say. However, there is always a lot of dispersion. Some people think that the inflation rate is going to be very high. Some people think it's going to be very low. Some people think we are going to go into a deep recession. Some people think that there is going to be a boom next year. This literature is trying to make sense of that evidence. How can we rationalize that? What models do we need in order to explain that? There has been a lot of work, especially in the last 10 years, trying to come up with good answers to this question. So in particular, two set of findings that seem to be very robust across different topics, different methodologies, and so on and so forth, is that both information acquisition and information processing are very important. So why some people think that inflation is going to be a lot higher or lower than other people? Well, they are not really paying attention to the same information. Some people are really up to speed with whatever the professional forecasts are saying. Some people are just not paying attention. They don't care enough. So when you ask them what the inflation rate is going to be, they just give you whatever comes to mind. And for information processing, it's a similar thing. Even when we see two individuals who face the same information set, they get the exact same signals. They seem to process the information very differently. And the paper that you just saw, you and present, it's a good evidence of that. So I think that what the next step in the literature is, and what I've seen lots of paper popping up that are trying to address this next question, is that should we really care about this? What are the implications of these subjective expectations? Does it affect the decisions that people make? Does it affect what we think of monetary policy, communication, and so on and so forth? And this is, I think, the space in which the literature is moving. I can give you one exaggeration for why you could say, you shouldn't care about subjective expectations, which I don't believe in this. I'm just telling you what, like, the devil's advocate might tell you. So, for example, let's say that you ask me what I think about the stock market return of Apple, whether the Apple stock is going to go up or down next year, and by how much, and I give you a number. And let's say that number is a lot higher than whatever the experts forecast for the Apple stock. And then you would ask me, hey, given that your expectations are so much higher than the markets, are you holding a lot of Apple stock? Are you trying to invest a lot of money in Apple? And my answer would be no. I believe in the efficient market hypothesis. You ask me a question, I came up with a number. That doesn't mean that I'm actively using that number in all of my decision making. So what we thought it would be very nice to do in this paper is to try to go against that argument by looking at decisions that are high-stake decisions. Let's try to take someone who, let's say, is deciding whether to sell their house or not. That's a $500,000 decision for the average subject in our experiment. Okay, let's try to feed them the type of information that we have documented. It affects their subjective expectations. And let's see what happens. Are they more excited about selling their homes or not? Did they sell their homes a little bit later or not? So what we're trying to do in this paper is try to provide some direct evidence that the subjective expectations really matter, that some people are putting their money where their mouths are. So I can tell you a little bit so this is a field experiment. I can tell you a little bit very broadly what the ideal experiment would look like. Ideally, it would take a subject, which is this stick person over here, who has put a property on the market. So let's say that this person, put their house, the house that they are currently living in, or some other property that they own, they put it on the market. And because they put it on the market, they will get some stream of bids in the future. Maybe next week, someone is going to give them an offer, or maybe the week after, or a month after, and so on and so forth. So these people will receive some information, and they will have to make a decision. Do I want to accept this offer, yes or not, or do I want to wait a bit more? And they may even have to decide whether to pull the property of the market. It could also be possible that, well, because I changed my mind, I don't think that it would be a good idea to sell the home. I want to pull it off the market. So think of a situation of a person that is in that situation. They own a house, $500,000 at stake, and they are deciding whether to accept offers or not. So let's say that this individual thinks at the beginning of the experiment that the home values in that particular market are going to grow by 2% over the next 12 months. So this person is thinking, look, for all 3-bedroom houses like the one that I own in this specific zip code, I think that they're not going to do too well. Maybe the home price growth is going to be around 2% the next year. So what we want to know is what would happen if we were to persuade this individual that rather than 2%, the home price growth is going to be a bit higher or a lot higher. So one ideal experiment would be to walk to people and flip coins, and depending on the outcome of the coin flip, tell them some information or some other information. Let's say that we have a market report that is a little bit more optimistic about home prices in that area. So if the coin falls heads up, we are going to show them that slightly optimistic report. And because of that, you can see on the left of my screen, this individual will say, hey, I thought that home prices were going to grow by 2%. Now I think it's going to be more like 4%. However, we also have this other report that is really, really optimistic about local home prices. And let's say that if the coin falls tails up, I show you that more optimistic report. And then this individual will say, hey, based on all of these optimistic signals, rather than believing that home prices are going to grow at the rate of 2%, they're going to grow at the rate of 10%. So now the question is, given these exogenous shocks to the expectations, given the fact that depending on the flip of the coin, this person thinks that home prices are going to grow at 4% or 10%, does it matter for the decision of this individual? What we would like to do is we would like to wait, let's say 6 months, and come back to this individual and ask them, hey, have you sold the house or not? And according to simple asset pricing models, what you would expect is that, if the coin fell heads up, this individual should be more likely to sell the home than if it falls tails up. Then whenever the individual thinks, hey, home prices are going to go up by a lot in this area, this individual is going to set a higher bar. Is going to say, hey, I'm going to sell the property, but only if the bid goes above this reservation price that is higher relative to the head situation. So what we could do is, if we were able to do this exact experiment, we would just wait 6 months and see what happens with the property, is it sold or not? And we would also like to quantify this relationship. Like for each percentage point, for each additional percentage point shock to the expectations, what is the corresponding effect on, let's say, the probability that the property has been sold? Okay, so we don't do exactly that, of course, but we try to use a field experiment that approximates this thought experiment as closely as possible. This was all pre-registered in the AA-RCT registry. I can give you the broad overview of what the experiment consists of. We just contacted 60,000 people who had recently listed their homes on the market. So you can think of people who listed their properties on Zillow and Redfin and those type of websites. And then we are going to reach out to those individuals, and we are going to send them letters, physical letters, not email, physical letters with some information about home prices. And within that information, we are going to flip coins to decide that to some people by chance, we are going to give them signals about the local home prices that are slightly more optimistic or slightly less optimistic. And then we're going to sit back and wait 6 months. We're going to check 6 months later, and we're going to use administrative records from the county assessor's office to check whether these individuals sold the property in the end or not. And then based on all of this information, we can test the hypothesis that I told you before. When by chance you give people more optimistic signals about local home prices, is it true that they are less likely to sell their properties? And if so, by how much? Can we say something about the elasticity of the decision to sell your property with respect to what you think your home price expectations are? Okay, so I will give you a brief preview of the findings, and then I won't have enough time to go through all of the results of the paper. I will try to make a little bit more emphasis on the actual methodological innovation, how to actually reach out to so many people, send them information, and so on and so forth. And the reason why I do that is because I think that this setting may be ideal for people who are doing PhD research, because as I will describe later, these experiments are quite cheap to do. Once you know where to get the data from, you can get them done really fast. So I think that, if I was a PhD student, this would be the type of experiments that would be probably the ones that I will be running myself, given, the restrictions in terms of resources and so on and so forth. So the preview of the findings is that we find that expectations have a significant effect on the decision to sell the property. Our favorite estimate, which combines survey data and administrative data and so on and so forth, says that the treatment on the treated effect is along the following lines. For each 1 percentage point increase in your home price expectations, what you think is going to be the appreciation of similar properties in the area over the next 12 months, the probability that you sell the property within the following 12 weeks goes down by around 2.45 percentage points. Because these two things are in percentage points, you can take the ratio of the two in order to come up with a sort of elasticity. So one way of saying is that there is an elasticity of 2.45 of market choices to subjective expectations, which is a quite high elasticity. The nice thing about this setting is because we have administrative data on these very large sample sizes, 60,000 people participating in the experiment, we can do all sorts of very sharp robustness checks, like bin scatter plots, doing event study analysis to look at the timing of effects, doing all sorts of falsification tests where, as dependent variables, we can use pre-treatment characteristics rather than the post-treatment decisions to sell the property, and so on and so forth. And the results are very robust to all of these checks. And the last piece of evidence that I probably won't have time to cover is that we do find evidence of some optimization frictions. So the first set of findings, if you want, you can take it as evidence that information frictions are important, that the fact that we are reaching out to some people with some information changes this meaningful decision of sell the property or not. But we also, in the same data set, find evidence of optimization frictions that are heavily inspired, actually, on Johannes and Teresa's paper on the 5 facts about portfolios. So what we do is we use this comparison of the individuals who are currently living in the property versus the individuals who are not currently living in the property. And the idea is that if you're currently living in the property, then you may care about home price expectations, but it's a whole lot of other issues that you may want to worry about. You may need to move because of your job. You may need to sell the house quickly so that you can get a mortgage to buy a new house. There are all sorts of things that you want to move, maybe worry about. But when you're a non-owner occupied owner, you are not currently living in the property. This is some other property that you own. So if you sell the property, it's not going to change your life meaningfully. So you don't have this type of optimization frictions. So if that was true, if optimization frictions are important, you would expect that people who are non-owner occupied property, who own non-owner occupied property, those people will be a lot more elastic because they don't have all of these other things to worry about. And that's precisely what we find. We find that if you split the sample in the owner occupied and non-owner occupied, it is still true that the elasticities are significant and large for the two groups. But in terms of magnitudes, they are a lot larger, 3 times as large for the non-owner occupied relative to the owner occupies. So if you don't have these additional optimization frictions, you are even more elastic to home price expectations. This also has the following corollary, which is that there is a conjecture in the literature that non-owner occupied properties are contribute disproportionately to home prices, the housing market speculation, and our evidence, I think, speaks directly to that literature too. Okay, so I already told you a little bit about the broader literature. I won't spend any more time on that. I want to give you some details on the research design. So you need to go through 4 steps in order to get an experiment like this done. The first one is you need to identify a sample of properties who are on the market. So you need to identify people who say, hey, my house is on the market. Those are the people who may end up selling the house in the next month, 2 months, 3 months, and so on and so forth. That's very easy to do. You can scrape it yourself. If you go to any website like Zillow or Redfin, you can just put a zip code, let's say, and you will have a summary of all of the properties that are on the market at that particular point in time. And this website even allow you to download the data directly. You don't even have to scrape it using Python or anything sophisticated like that. So the second step is, okay, you know what the addresses are of the properties, but you don't know who the owners are or where the owners are living. So that's the trickiest part. If you go to, for example, one particular property, this is a screenshot from the Redfin website, you will notice that there is this information, and in the bottom right of this table, it has a number, which is the APN. That is the unique identifier for the property that identifies the lot in which a property is located. And with this APN, you can merge this data to all of the data from the county assessor's office. That includes not only the owner name, but also the owner's address. So this is just one example. We didn't, of course, do it manually. We did it like with the Stata in just one step. But I can just show you that if you wanted to, you could do it in your computer right now. You could take this parcel number, go to a corresponding assessor's office, do a search with that parcel number, and you will get a search result that looks like this, where you can see the address of the property, but most importantly, the name of the owner of the property and the mailing address of the owner of the property. This is very important because we need to reach out to these people, so we need to know exactly where they live. We can't just send the letters to the property address and hope that it's going to get eventually to the owner. So this is the second step. We know the properties that are on the market, on any specific market in the US, and we can figure out what the owner's name is and the address of the owner. The third step would be to send them the information, to reach out to them and say, hey, I'm going to give you a slightly more optimistic signal about the local home prices, and to other people who want to flip the coin and give them a slightly less optimistic signal. So how do we do that? We do that by regular mail. We just hire a mass mailing company, and they do this all the time. They can print out like 100,000 letters in one day if you needed to. This is like no big task for them. So we did this project through the UCLA IRB. So this is an outside of the envelope. It has information about the researchers and the address and the name of the owner of the property. And then within the envelope, there is a letter, and this letter will have some information along the following lines. Hey, we are researching at UCLA. We noticed that you put property on the market. Here is some information that may be useful. So we provided information specifically about future home prices. However, you could use the same research design to study any hypothesis that you wanted to. So if you wanted to give people information about, how, let's say, climate change is going to affect the local home prices, you could give them that information too. Or if you wanted to give them information about the quality of public schools or anything that you could think of, then you could, do an intervention about that as well. So the fourth and final step is to wait. You have to sit back and wait a few months so that the owners have the opportunity to decide whether to sell the property or not. And once enough time went by, what you can do is you can use the administrative records in order to check who sold the properties, who didn't sell the properties, and for those who sold the properties, you can even figure out, the name of the owner, of the person who bought the property. You can figure out the price at which the property was sold, and so on and so forth. Again, we did this with massive data sets. I'm just giving you a screenshot to show you that you could even do it in your computer right now if you wanted to. So if you were to search again 6 months later for this specific address that I use as an example, you will see that eventually there will be in this website a timeline that says not only when the property was listed and the price at which it was listed, but also the exact day when the property was sold and the exact price at which the property was sold. So that's the last piece of information. You can put all of these together and run the type of regressions that I will show you in a second. So by the way, how much time do I have left, Johannes? Oh, your mic is off.
10 minutes, sorry, about 10 minutes. We have a break
Okay.
after you, so you can go a bit longer, and I think we have the next presentation at 4 Eastern.
Okay, that sounds great. Okay, so now I told you that we are going to randomize flip coins and randomize some of the information that we put in the letter. We have two sources of exogenous variation. One, which is the number 2 over here, is the disclosure randomization. This is when you randomize that you show some information to some people, but you don't show to another people. That's the most traditional type of information provision experiment. We also have another source of randomization that is, even within the people that we show signals to, we can randomize the source of the signal. And this is a way in which we can get this type of fine variation where we say, hey, I give you a signal that is slightly more optimistic, and I give this other person a signal that is slightly less optimistic, and that's all based on a flip of a coin. Both of those two sources of those two designs of information provision experiments are completely valid, and I've used them separately in other papers. What we wanted to do in this paper is, because we had so much power, we could do it with such large samples. We wanted to have both in the same experiment, so we can, pull the two in order to get more precision, but also as a robustness check, look at the estimates using one research design or the other research design on the other side and see whether they are consistent. And that's precisely what we find. It doesn't really matter whether you use the source randomization design or the disclosure randomization design. In both cases, you get estimates that are pretty close to each other and also independently statistically significant and precisely estimated. So for that reason, I don't have a lot of time, so I will just give you a glimpse of what the source randomization looks like. So you could imagine that you have a subject and you can check based on data what happened to the home prices in that particular area over the previous 12 months. So you could compute that number. Let's say that for this particular subject, in that zip code, home prices went up by 1.5% over the last 12 months. You can send a letter saying, hey, this is the information. Over the past 12 months, home prices went up by 1.5%. But you could think of other sources. The other source could be, what if instead of telling them what happened over the last 12 months, you tell them what happened on average over the last 2 years, yearly? So if you do it for this particular subject, you will find out that home prices went up by 3.2% rather than 1.5%. And you could keep doing this. So you could say, hey, rather than giving them information about the past, I could come up with my own forecast. I'm going to feed my own statistical model and tell you what the prediction of my model is, or I could use other people's forecasts. You could say, hey, according to the CILO research team, this is what is going to happen, is forecasted to happen in this particular home price. So what the source randomization is going to do is it's going to be using this random variation that is generated by the fact that I could show you, let's say, 6 different signals or 5 different signals, and by chance I pick one specific signal. So you can think of normalizing the information about the past year as the baseline signal. So the relevant variable in the regression is going to take the value 0 if you get this signal. If you get the second signal, because it's 3.2% rather than 1.5%, this information shock variable is going to take the value of plus 1.7%. This is relative to this other baseline signal that I could have chosen for you. I'm giving you a signal that is 1.7% more optimistic about the future. And then if you pick the third signal, which is the forecast, you are going to have this variable with a value of plus 3.6, again, relative to that other baseline signal that I could have chosen for you. The signal that I actually chose by you by the flip of a coin is 3.6% higher. By the way, this is not very different from what we have done in other papers, both in terms of home price expectations, but in the context of surveys. So we have done this in the past. People seem to incorporate all of these signals. The only difference is that now we are doing it in a field setting where we can check whether people sell their houses afterwards or not. So this is a sample of what the letter looks like. So all of this information in the letter that doesn't say information or information details is totally the same for all of the subjects in the experiment. It provides background about the study. The part that we truly randomize is this part over here, which are these tables with information. So this is a sample table for pass one. This is the information source about what happened over the last year in your area. So you can see we are showing to these individuals that the median price of the properties was $339,000 in May of 2018, and this experiment happened in May of 2019. And as of now, it is the home prices are the median value is $343,000, which implies annual price growth of 1.2%. You can do the same thing for the past 2 years, and you can have different forecasts. Forecast one, forecast two, forecast three. Based on different assumptions, you can try to forecast what's going to happen in the future, and this will end up giving you different signals. One is 2.6, another one is 4.1, the other one is 3.5. So the point is that for everyone, we have these 5 different signals that we could show, and the idea is that we are flipping a coin to decide where we show you one or the other. So let me tell you a little bit about the regressions. So the dependent variable in this regression is related to some survey data that we collected in a complementary experiment. So we asked people the traditional question of, over the next 12 months, what do you think is going to happen with the home prices in your area? And they can give you any numbers, 1.2%, minus 3%, 10%, whatever they want. And the right-hand side variable, the independent variable, is this information shock. We did this same type of experiment where we would randomize precisely which source you are shown. And what we find is that the information shocks that we give to people have a very significant effect on their subsequent expectations. So for each percentage point increase in this information shock that I give you, individuals expect home price, have home price expectations that are higher by around 0.2 percentage points. So you can think of, there is a pass-through. The pass-through is not perfect. Some individuals seem to agree to disagree with the feedback that we give them, but on average, they do incorporate the information. And these results are, again, very close to what we find in other survey experiments that we did in the context of home price expectations in the past. So now I can turn to the behavioral data, to what actually happened in the field experiment. When we send to people these letters with information shocks, did it change the probability that they sell the property within the next 12 weeks, let's say? This dependent variable takes the value 100 if the individual sold the property within 12 weeks after we started sending the letters. And the right-hand side variable is the information shock, again, with a rich set of controls and so on and so forth. What this coefficient is telling you is that for each additional 1 percentage point shock that we put in the letter, the probability that this person sells the property goes down by around 0.33 percentage points, and this is highly statistically significant. The negative sign is consistent with economic theory. If you think that your asset is going to grow in value, appreciate more in value in the future more, then you should be less excited about getting rid of that asset. In terms of economic magnitude, this is just an intention to treat effect. This is the effect of us sending you information. It's not really the effects of your expectations. In order to get a more meaningful quantitative measurement of how elastic individuals are to their subjective expectations, we need to use other sources of data. I will get to that in a second. We can reproduce this analysis, but rather than looking at what happened with the probability of selling the property 12 weeks later, we can look further down into the future. We can say, hey, what's the effect on the probability of selling 20 weeks later, let's say 6 months later. We find point estimates that are very close and also very precisely estimated. And we can do all sorts of falsification tests. One falsification test could be, for example, let's use dependent variables that were measured prior to us sending the letters. Because they were measured prior to us sending the letters, they should have no effect whatsoever. The letters should have no effect whatsoever on them. So one of them could be whether you sold the property up to 1 day before we actually send the letters to the subjects. We shouldn't see any effect on that. We don't see any effect whatsoever. We can also look at a dependent variables, like, for example, what's the number of days that the property was listed for, up to the point in which we started sending the letters. We find no effects whatsoever. I will show you more details in a second. So this is what a pin scatter plot of the relationship between the information shocks and the probability of selling the property look like. The effects look very linear. We do all sorts of additional tests, like, for example, whether people who are updating up versus updating down, you may see different effects. We don't find any evidence of that. We don't find evidence that, the effects are driven by the very optimistic or the very pessimistic signals either. Because of this context, we can also do an event study analysis. So what happens is that we send letters, and then all of the letters don't get right away because all of these people are in different states. So for some people, it may take 1, 2, 3, or up to 6 weeks for them to get the letter, but most importantly, open it. The letter may be sitting in their mailboxes for a while. These red areas over here tell you what's the percent of people, of subjects, who have opened the letters according to one of our proxies at each point in time. So this is more or less telling you that if you look 1 week after we send the letters, only 10% of people had actually looked at the letters. If you look 2 weeks later, it went up to maybe 20%. And then once you get to 7 weeks later, we estimate that everyone who was going to ever read the letter already read the letter. So what you would expect given this timing is that the effect shouldn't start right away after we send the letters. They should start, intensifying as more and more people, more and more of the subjects get the letter, and then they should taper off after we say all of the letters were open. And that's precisely what we find. So these point estimates to the left, they tell you that the information shock that we put in the letters didn't affect the decision to sell for those individuals who sold the properties even before we started sending the letters. And then what you can see here is that it's not that the effects materialize right away, but as more and more people were receiving the letters, you see these effects of information shocks intensifying at around 1 or 2 weeks after we are done, all of the letters are done being open. You see that the effects pretty much stabilize and remain at the same level. And even if you look 6 months later, the effects are still quite significant. So this is another way of saying is that it's not that our information shock convinced a person who was otherwise going to sell 2 weeks later to sell 3 weeks later. What we are finding is that some people were planning to sell right away within 1 or 2 months of us sending the letters, and they decided to hold on to the property for at least 6 months. Now we have more data, so we can even look at effects a year later if we want to, but this to us seems pretty significant already. So we can do all sorts of falsification tests along the lines of use other dependent variables that we shouldn't observe effects on, like, for example, the price of the property or the number of days that the property was listed prior to us sending the letters. We standardize all of these coefficients so that they can be comparable across different regressions. And what we find is that, as you would expect, that when you look at the outcomes that you really should expect effects on, like probability of selling post-treatment, you find these significant effects. When you look at outcomes that are pre-treatment, you find all effects that are close to zero and precisely estimated. Again, this was an experiment. Like, this is exactly what you would expect. But given the large effects that we find, we thought it would be very important for us to double check and make sure that all of these effects are real. There is nothing weird going on with the specifications. So because I only have, I'm already over time, I will just tell you a little bit about the quantification of effects, what we need to do in order to transform this minus 0.33 coefficient into something that has more economic sense. We need to account for two sorts of non-compliance. We need to account for the fact that when you shock an individual with information, there is not a rate of 1 in the terms of the pass-through. It's not that you convince absolutely everyone that your information is right. So we cannot use the survey experiment in order to account for that. The second source of non-compliance is the fact that we are sending a bunch of letters, and some of these letters may get lost in the mail, or they may get returned to us, or they may get, someone might read it, but by the time it's too late, they already sold the house at the point that they read the letter. So we have rich sources of data from the USPS that we can use in order to account for that form of non-compliance. Once we put those two forms of non-compliance together, that's when we arrive to this elasticity of minus 245. This fact that for 1 percentage point increase in your expectations, the probability that you sell the property goes down by around 2.45 percentage points. So as far as elasticities go, this is pretty elastic. It seems that these individuals are not just coming up, ex post rationalizing and coming up with some, expectations. It seems that these individuals are using these subjective expectations in an important decision like selling their properties or not. So last, to conclude, I want to have a little bit of time to tell you about not only the findings of the papers, which we're excited about, but also about the methodology. So we think that this methodology can be applied to explore other hypotheses, in finance, urban economics, behavioral economics, and so on and so forth. Some of the advantage of this setting is that you have this hard outcome, whether people sold the property or not, that you can measure with administrative data. This is naturally occurring context. People are putting the market, their homes on the market on their own. We are not forcing them to. And it's also a high stake context. There is $500,000 at stake for the average subject in our sample. This is all based on 100% publicly available data. So it's not that you need to ask like for Zillow or Redfin for their permission or their data. Everything that we did with data you can download from some FTP somewhere online. It's super cheap. The cost per subject of doing this intervention is just 25 cents. Nowadays, you can barely do experiments on Mechanical Turk for this cheap. And the other important thing is that it's scalable to millions of subjects. So we did with 60,000 people just because we wanted to get the experiment running at some point. But if we spent a little bit more time, we could have added other counties to our sample, and presumably you could do it with like 1 million people at once if you wanted to. There are lots of people being sold at any given point in the US market, so there is really no ceiling to how big these experiments can get. And we are documenting the implementation of this experiment very carefully. We're going to upload an appendix where we are going to provide very detailed account of, how we collected the data, what things you should worry about, and so on and so forth. If you are ever interested in running one of these experiments for your own PhD research, don't hesitate to reach out to us. We are happy to share data with you, share our code, give you tips on, how to hire these companies, what things to worry about, and so on and so forth. That's pretty much it, Johannes.
Thank you so much, Ricardo. Again, this is a sort of an ambitious exercise. I mean, the cheapness. I want to also it's very kind of you to offer the help, and I think a few things on the implementation side. I do think we want to come back to in the panel, because I think this is exactly, in some sense, it's actually very encouraging to see sort of that this is entirely doable. I would. In fact, and quite honest, when I looked at this, I thought this is just a monumental undertaking, and I think certainly in terms of time investment it is, but actually the cost per subject is really very low here. Is that just because you get some sort of non-profit mailing rate with USPS that drives it
exactly
down?
That's absolutely right. So if you are doing this from a university, if you are either a student or a faculty, you can ask for the nonprofit permit from the university. They just give you a code or something like that. You share that with the mailing company and you get a heavily discounted rate, which I think is 12 cents per letter. So this 25 cents is half of it is for the actual postage. The other half is for the cost of printing out and mailing all of the letters. They have other machines that do this type of things. And it's a very competitive industry. So if you ask for quotes from 5 different mailing companies, all of the quotes will come very close to each other. It's a very, very competitive industry.